Greetings, I'm ICG Grace and I'm here to explain the robot class. So here we have a robot class. Inside it, you will first see the attributes that we declared, which are all private to ensure encapsulation. The name and the model number are strings, while the parts of the robot are stored as objects within the robot class. And we also added an is-activated boolean initialized to false to indicate that the robot is off initially. Then here is the constructor. These lines allow us to assign input values of name and model number to the robot. Then here are the getters and setters, which can be used to let the user change or check the robot's attributes. Now onto the methods. Here is the assemble method, which takes each part of the robot as the parameter, and then each part is then assigned to the robot. The next one is the power up method. This method turns on or activates the robot. It calls all of the activate method of each part. It also sets is activated to true to indicate that the robot is now turned on. And it also prints a message to let the user know that the robot is ready to function. The next method is the combat method. This method first checks if the robot is activated, and if it is, it prints a message to let the user know and then calls the weapons attack method. Otherwise, it says the arms is not yet activated. The next one is the move method. It's similar to the combat method. It first checks if the robot is activated, and then if it is, it calls the legs move method, and if it is not, it tells the user that it is not yet ready. And finally, here is the scan area method. This only works if the robot is turned on. It calls the head scan area method if it is, but if it is not, it tells the user that it is not yet activated. For the next parts, you might notice that all of the robot's part classes are inside the robot class. This is because the robot is composed of those parts, and it indicates a composition relationship.
Dangal greetings everyone, I'm Gonzales Maria Manuela and I'm going to explain the head class inside the robot class in our project. So first, here is the public class head, and here are the attributes, which is the private string iColor and private string sensor type. Here is the constructor, the getters and setters for this class, and the two methods. So here are the two methods, which is the public void activate and public void scan area. So in public void activate, this will activate the head, the robot's head and its sensors and visual system. So this will let the user know that the heads is now activated and will display the eye color and the sensor of the head. And here now is the public void scan area. So this method is to scan the environment of the robot. So it will print this scanning the surroundings for threats and an enemy has been found.
Greetings, I am Jasper Asi and I will discuss or tackle about the torso class. So here, public class torso. This declares a public class named torso. Attribute, private string power source, a private variable that stores the type of power source, for example like battery or solar and others, and it is private, so it can only be accessed inside the class. Constructors, this one. This power source equals power source. This constructor is called when you create a new torso object. It takes one parameter, power source, and assigns it to the class power source attribute using this keyword. Setters or setter, then getter. So method, this one to method. Public void activate. When it called, this method stimulates the activation process of torso, and it prints a sequence of steps to show what happens when the torso is turned on. Greetings, I am Jasper Asi and I will present the public class arms. So public class arms, it is declared as a public class named arms. Attribute, private int strength level, a private integer that stores how strong the arms are, and it is being private, so it means it cannot be accessed directly from outside the class or other class. Constructors, or rather constructor. This dot strength level equals strength level. This constructor is used when creating an arms object, and it takes an integer and sets the strike level to that value. So here naman yung getter and setter sa class na to. So method activate, public void activate. It simulates the action process of the arms, and it displays the system analysis and a message saying the arms are ready for use.
Dangal greetings, I'm Veronica Cojeres and today I will be explaining one of the essential parts of our robot Java program, the leg class. Let's start with this line of code. Defines our leg class since it inside the robot class, it treated as a part of the robot, specifically the legs, which help with movement. And here we declare a private variable called mobility level. This value tells us how mobile or fast the robot's legs are. The higher the number, the faster the robot can go. And this is the constructor. When we create the legs, we give them a mobility level and this line set the value. And this setter method allows us to change the robot's mobility level later on, in case we want to upgrade or adjust the speed. And here, the getter method, it simplify returns the current mobility level. So other parts of the program can check how fast the legs can move. And this method activates the robot legs. It prints out system details like the mobility level and confirms that the legs are powered and ready to move. And this move method simulates the robot walking or running. It calculates the speed by multiplying the mobility level by 3, then prints the result along with the robot's name. And that's how the leg class works. It handles movement and speed, which are crucial for any robot in action. And that's all. Thank you.
Dangal greetings. I'm Anthony Siambat and today I will explaining the weapon class in our project, the robotic assembly system for a futuristic robotic factory. So let's start. So we have class declaration on this line, declare a public class named weapon. Next we have attributes. So that these are the properties of the weapon class. We have weapon, weapon type, it's a string that represent the type of weapon. Next we have power lever, and that indicate the weapon power level, which could affect its damage output. So both attributes are marked as private, meaning they cannot be accessed directly from outside the class. Next we have the constructor. So the constructor, this is a special method that is called when an object of the class is created. It initializes the object attributes. The constructor takes two parameters, the weapon type and the power level. So this keyword is used to refer to the current object attributes, distinguish them from the parameter. So we have getter and setter. So the setter for a weapon type. So this method allowed you to set the weapon type attributes. However, it incorrectly attempt to set power level again, which is not intended. Next, we have the get weapon. So here, the getter for weapon type, this method return the current value of weapon type attributes. Next, we have set power level. So this method allows you to set the power level attributes. Next, we have get power level. So this method return the current value of the power level of attributes. Next, we have method. This method stimulate that activate of the weapon system. It prints out of weapons type and power level, indicating that the weapon is being prepared for use. Next, we have public void attack. This stimulate that attack by the weapon. It's calculate the damage based on the power level. In this case, simple doubling it and prints out the message indicating the attack and the damage deals. So that's all. Thank you.
Greetings everyone, I'm April Jazz Franco and I'm here to explain the main.java program. Import Java the digital scanner. It imports the scanner class so we can get a user input from the keyboard. The next one is the public class public static void main string args. This this is the starting point of the program. The main method is where the program begins execution. The scanner line and the robot assembly line is a scanner object named scan is created to read input from the user An instance of robot assembly line is created, which will later to be used to build the complete robot. Next one is the declaration of variables, which is contained of name, model number, eye color, sensor type, power source, weapon type, and etc. These are variables will store the user input for different robot attributes. These lines of code which indicated to the name of the robot, model number, its eye color, its type of sensors, and its power source. The these lines of code it prints a message asking for the robot's name, model number, eye color, type of sensors, and power source, then reads using the scanner the next line. Next one is the numerical input, which is the system that automatically enters strength level 1 to 100. It reads the robot strength level, then scan that next line is used after reading an integer to clear the input buffer, as well as this tree, the mobility level 1 to 10, then enter its type weapon and its power level 1 to 100. This lines of code is for creating a robot and its part. A new robot object is created using the name and model number provided. Now, the inner components like the head, torso, arms, legs, and weapons are created using a nested classes inside the robot class. The assembly robot is it sends all the parts to build robot method in the robot assembly line class, which assembles everything into one robot object. Then in this one, the robot power up, it calls power up method for robot to be ready to function. The next one is the in choose do, then system that out at print line menu for robot's action. It's a dual loop and used to repeatedly show and where the user can command the robot. The scan area in the number one, two, combat mode, three, move robot, four, terminate robot, then enter robot's action. It prints the available actions and lets the user pick one by entering a number. This runs of code 71286. Based on the user's choice, the corresponding robot method is executed. The scan area, combat, and move are method that define robot's behavior. Then the case 4 is ends the loop by breaking out after printing a shutdown message. Then the while choose exclamation mark equals to 4, the loop repeats until the user chooses option 4 to terminate the robot. That's all. Thank you for watching and on to the next reporter.
So, dangal greetings. I'm Ira Christine Librutas and I'll be explaining the robot assembly line. So, this robot assembly line class is responsible for constructing a complete robot by assembling its individual. So, it contains a single method. So, we have build robot, which takes the robot's name and model number along with its parts, its head, torso, arms, and legs. So, and weapon. When this method is called, so it begins by printing a message indicating that the robot is being built. So it creates a new instance of the robot class using the provided name and model number. And after that, the robot object it calls assemble method to attach all the provided parts of the robot. So once the assembly is complete, a message is printed to confirm that the robot has been successfully assembled. The fully robot is then returned. This class demonstrate the concept of composition in object-oriented, where the object robot is made up of multiple smaller specialized. So next is I'll show you how the robot program represents a creating and operating a robot using user input. So when the program starts, it prompts the user to enter details, of course, about the robot, such as its name, model number, eye color, sensor type, power source, strength level, mobility level, weapon type, and power level. So after this, entering all the information, the program calls the robot assembly line, which I've discussed the class recently. So to assemble the robot using the provided parts, this is confirmed with the message building robot followed by robot name assembling complete. So indicating the robot is successfully built. So next is the power up method is called it activates each part of the robot in order: head, torso, arms, legs, and weapon, each part displaying its own activate message, including its configuration and a confirmation that it's ready. So once all components are activated, the robot is declared ready for use. So the program enters loop showing a menu with four options: scan, area, combat mode, move robot, and terminate robot. So depending on the user selection, the robot performs different actions. For example, choosing scan area triggers the robot head to scan for threats, while combat mode makes it attack with its weapon, showing calculated damage based on power level. So selecting move robot uses the mobility to level, calculate and display the robot speed. Finally, so eto na, choosing terminate robot ends the loop and simulates shutting the robot down. The output demonstrate how user input drives object behavior through method call, showing principle of composition and encapsulation.